Louis Dion-Marcil, and he'll be talking about exploiting caching servers. Please welcome him to the stage.
All right. So hi everyone, welcome to Black Hat, and thanks for attending this talk. So the title of this talk is Edge-Side Include Injection, Abusing Caching Servers into Server-Side Request Forgery and Transparent Session Hijacking. So that's a pretty long title. It's meant to mention some of the many things that you can do with Edge-Side Includes, especially when you're injecting it. So for the rest of this talk, I'll be referring to ESI when I mean Edge-Side Includes, because it's much more convenient. So during this talk, we'll be talking about ESI and the problem that it was created to solve. We'll talk about the problem that it created and how we can abuse that. And then we'll talk mitigation and migration. So my name is Louis Dion-Marcil. I work at GoSecure in Montreal. And this is where we initially discovered ESI. So to give a bit more context, ESI is basically a new class of attacks, which is targeting ESI-enabled caching servers. So we discovered this vulnerability or this class of attacks on site at a client. So it's actually my colleague, Laurent Desaulniers, who was doing a caching server configuration review for one of our largest clients, basically a large ISP back in Montreal. And they wanted a security overview of their caching efforts. So basically every edge server on their infrastructure, they wanted us to look at the configuration. And we kept seeing references to edge-side includes. Now, all of our team is pretty experienced with web app and testing and security stuff, and no one's ever heard about that. So we started looking about what is ESI. And we found the first and last, so the initial and last specification for ESI, which dates from 2001, which is 17 years ago. And every single vendor that we analyzed had always some weird screenshots predating from when I wasn't even in high school when someone made this. So you have word art and documentation, so we had a pretty bad feeling because I don't know if you were doing web development 20 years ago, but security was the least of everyone's concern. So let's describe ESI before talking about exploiting it. So to do a brief overview, let's look at a very primitive web page example. So you have a weather website. Now, to the end user, this is a single HTTP response. There's nothing to it. But to the ESI-enabled engine, this might be multiple fragments. Now, these fragments are there for one reason only, which is you're able, when you use ESI, to invalidate individual elements of your web page. So here, for example, the website has a graphical interface. So you have the labels, but when you think about it, these labels don't have to be invalidated. They're not likely to change anytime soon, whereas the actual forecast data might change within the hour. So using ESI, you're able to invalidate the cache entry for subsets of a web page. Now, of course, if you leverage ESI properly, you're going to have a major increase in performance, and of course, you have malleability to caching. So it's pretty good technology. However, there has to be a way for the application server to tell the caching server where individual fragments begin and where they end. And this is done through fragment markers. So fragment markers are basically XML tags which are prefixed with ESI. Now, as you can see in the middle of the slide, you have a simple ESI tag. So your action would go after the colon, and then you sometimes have attributes shown in the mix. These tags are in the HTTP response, meaning that they're going to be parsed by the ESI engine that is sitting on the caching server when this response goes through the server. So your HTTP surrogate, which is your ESI engine, it could be a load balancer, a proxy, or any cache server, will often require that you send specific HTTP headers to say, hey, I have ESI tags, please parse them. However, we found that if your website is leveraging ESI, then it's probably enabled everywhere, so injection is pretty easy. So we'll see two features before talking about exploitation, just because it's a bit obscure right now. So the first one is ESI includes. ESI includes, here you have a very brief example, so you have two pages sitting on two different servers. So you have page1.html and then page2.html. You can see in page 1, you have an ESI include pointing to page2.html. Now here, two things can happen. You can have a cache miss, or you can have a cache hit. So if page 2 is already known to the ESI engine, it's just going to replace it as is by filling the blank. So it's going to remove the ESI include tag and it's going to replace it with the entry of the cache entry for page 2. If it's a cache miss, meaning the content of page 2 is invalid, or if the caching server has never seen that file, it's going to request this file. it's gonna do a GET request on /API/page2.html. So when you request page 1, either way, you're gonna have the content of page 2 in the HTTP response. Now to illustrate how this works, let's look at a very brief diagram. So you have your clients, your load balancers, and your application servers. So your clients is gonna send 1.html, and the caching server, since we're looking at a cache miss, is going to send the request upstream. Now, the application server is going to respond with an ESI tag in the HTTP response. The application server, since ESI tags are in the HTTP response, the load balancer knows to parse them, and the side request for page 2 is sent to the API server. Now, API responds. Now, step 5 and 3 can be concatenated together before sending it back to the client. So this is ESI includes. Now let's look at our second features before delving into exploitation. You have ESI variables. So ESI variables are also pretty easy to understand. They're basically attribute-less ESI tags, which will allow you to expand information about the current metadata of the HTTP transaction. So you usually have these sort of variables. So you have access to HTTP user agent, the query string, the cookies. And basically, this is going to give you access to all of the metadata in order to take decisions on your caching efforts. So for example, if you have a cookie for which the name is language and its value is French, then you should probably do an ESI include of the French logo of your organization. So that's just a very brief example. So with this knowledge, we can start seeing where the vulnerabilities lie. So we know two things right now. We know that ESI tags are sent by the application server. We also know that they're sent through the HTTP surrogate, and that this surrogate is going to parse those. And this leaves us with a very interesting and dangerous question, which is how can the ESI engine tell which tags are legitimate and which tags are being injected by a malicious user, just like cross-site scripting? And that's the problem. It can't. And that's a pretty big design flaw. So if you think about ESI injection, this snippet is vulnerable to it because everything that is in the city-get parameter gets added to the HTTP response. So if someone puts ESI variables pointing to the HTTP cookie session ID, well, the HTTP surrogate is going to look at this and expand it, and you're going to get that answer back. That's pretty dangerous considering that PHP session ID, if you've done any PHP, is an HTTP-only cookie, meaning you can probably do session theft. So to do that, we'll look at our first ESI implementation, Apache Traffic Server. So I looked at Apache Traffic Server for two reasons. First of all, because it's used by high-profile organizations, so that's always a plus. So I know for a fact that Yahoo uses it, and Shodan also talked about Apple and Comcast. That's yet to be confirmed. So I looked also at ATS for another reason, which is they added all of the ESI specification and they added bonus features. Some are very interesting, and one of the feature is cookie whitelisting, which might sound like a great idea because if you have ESI injection, you can't just refer to the PHP session ID. It's going to return nothing. However, by looking at the documentation, you also see that there's a new variable called HTTP header, which allows you to refer to the HTTP header cookie, meaning that you can effectively bypass the cookie whitelisting altogether. So that's a pretty big oversight. So that was reported and fixed 2 months ago, and it basically allows you to do ESI injection leveraging cookie, basically stealing cookies. So for that, let's do a proof of concept with Apache Traffic Server. So I built the following payload. However, you can use multiple payloads. They're all going to work. So I built an image tag that is pointing to my attacker-enabled server, so evil.local, for which the file name that is going to be requested by the victim's browser is an ESI tag. This tag, of course, is basically going to reference to the victim's cookies. Now, once this tag is sent by the application server to the traffic server is going to expand it to the user's session cookie, and so the browser is going to request this file, thinking an image is sitting there. So let's look at our first demonstration. So I built a video because it's much safer. So we have a very basic website that I built. You have two browsers. So on the left-hand side, you have your victim. On the right-hand side, you have the attacker. In the middle, you have all of the database content for the messages, because it's a message board. So you can see what the data looks before transiting through the cache server. On the bottom side, you have evil.local. So basically, all of the GET requests are going to be printed there. So now, our victim is going to use the website just to show how it looks. The victim sent a message. Now the attacker is going to put the payload that we just looked at. So basically our image tag that is pointing to evil the local, for which the file name is going to be anyone's session cookie. So we refer to the HTTP header cookie, and we send the payload. And you can see in the database, once it's sent, you have the ESI variable that is going to be stored in the database as expected. Now, by sending the payload, the attacker effectively attacked themselves. So we're going to receive HTTP request right here with our own session cookie. Now we're going to wait for the victim to refresh the page so that they attack themselves. And we're going to get a response back. So now we have the session cookie for the victim, and we're able to take over their session. So we're going to look at all of our cookies right now, and we confirm that session cookie is HTTP only, meaning that JavaScript could not have accessed that cookie. We're going to replace our own value with the one that we just stole. We're going to save and refresh. And there you go. So we just did JavaScript-less session hijacking using ESI injection. Okay, let's just go back here. Okay. So yeah, so now we know we can inject ESI tags, we can leak HTTP only cookies, and we don't even need JavaScript. But just like XSS, it's a bit boring because, well, we have to wait until the victim reaches a very specific web page. For example, if you find XSS on an obscure web page, which is a feature that no one uses, well, you can't exactly leverage this. So let's try to crank the impact up a notch. So the second feature that I looked at is Oracle Web Cache. Oracle Web Cache is also a high-profile target to me, Oracle, and they also implemented bonus features, some of which are insanely dangerous. So the first one that I was interested in is the ESI inline tag. The ESI inline tag allows you to take an arbitrary cache entry and replace its content. What could go wrong? So here you have jQuery.js that is going to be sent in the ESI inline tag, and the content of the tags is the content that you want inside of that entry. So here two things are going to happen, right? So you have jQuery.js, it's going to get overwritten with the content here, and as you can see, the highlighted payload is basically just an AJAX request, so an asynchronous GET request to my server, which is evil.local. And then the second thing that's going to happen is that every time someone requests jQuery.js, this ESI variable is going to be expanded, which is going to be sending their own session cookie. Now, we don't have any whitelisting on this vendor, so don't have to find any tricks to refer to the cookie. So this is going to be the URL that every single browser using their website is going to send me. This is their session cookie, which is HTTP only once again. So let's look at our demonstration. So we basically have the same website, right? But now it's super safe because the sysadmin added HTML encoding, and since it's the same ESI the same char set, the ESI is no longer valid. Now you can see in the DOM, we also have jQuery.js that is being requested on every single page, meaning that if I'm able to replace this file, I'm going to attack every single user of the website. So jQuery is working fine. Now our attacker is going to look to see if the HTML char set is available. Notices that now they're HTML encoding, so they basically mitigated ESI. Now our user is going to see that there's a new feature called the user list. So the user list has a search feature for which everything that is put into the search is echoed in the HTTP response. So that could be a good vector for ESI injection because it's going to go through the caching server. So we're going to test for HTML entities and they're not escaped. So that's a pretty good example of where I can do ESI injection. So we're going to take our payload, which is the same one that we just looked at. So jQuery.js is going to be overwritten. We put it there and then we press submit. And it should be good. Now jQuery.js should be overwritten. So now our victim is going to refresh the page. And you can see the file has been overwritten with the AJAX query that we just looked at. Now we're going to make the victim refresh any page on the website. jQuery.js has now changed, so the cache is invalidated, so the user is going to request the file, and we obtain their cookie. So now we can do, basically, we can overwrite any file on the web server, and now we just stole basically their session. I'm not going to go through the whole stealing their session, changing the cookie, because you saw that already, but basically we just did arbitrary write of cache entries, and also we can leak HTTP cookies. So JavaScript helped here. It's not required. You can use anything, basically. You can just do like rewrite index.html. That works fine. All right, so that's pretty dangerous. So how do you mitigate this? So if you're using mod security, which you're probably already using, some of you, be sure to have the core rule set from OWASP. So this is going to leverage basically mod security in order to escape HTML. So any HTML tag is going to be escaped. And since it's the same char set as ESI, well, you're good. However, you also have to do proactive escaping. When you think about it, a JSON response has no real reason to have their HTML encoded or escaped because the browser already knows through the content type not to evaluate it. But I'm not attacking web servers. I'm not attacking clients. I mean, I'm attacking caching servers. So I'm able to put ESI tags in there, and some ESI implementations will let me do that. Now here, of course, I have a small problem, meaning I have invalid ESI tags because double quotes, right? However, ESI implementations have very flexible syntax. So, for example, Apache Traffic Server will allow me to just drop the double quotes, and it's just fine. So you can do server-side request forgery, right? So here's a fictive REST API. So you have API/me, for which my full name as a response is Louis Diomarcil. Now I can change that value for an ESI include tag without double quotes, and that server is going to send it back in the response. Now, since there's an ESI engine sitting on top of that, it's going to go fetch this file for me because it thinks the web cache is being instructed to query this file. So I changed the content type to HTML just to better illustrate how that works. So you have the green area, which is basically the JSON payload, and then the reddish area is the ESI include for which we use to do server-side request forgery. So to reuse the same graphic, this is basically what happened, right? So we have /me, for which we had a response with an ESI tag in there. The caching server saw that and requested server status on a different server. We got the response back. Step 5 and 3 get concatenated and sent to the user. Now you have to keep in mind that most ESI engines will only do ESI request for preemptively whitelisted hosts, meaning that when you configure ESI, you're going to have to say, I'm allowed to do ESI includes of XYZ server. So if you're not requesting XYZ, you're not going to get anything back. However, a lot of them are also going to allow you to just do ESI include of basically anything, such as Squid and language-specific implementations like Node.js implementations of ESI. So to perform manual detection, someone on Twitter called Alex Birsan came up with a pretty smart solution. So he's leveraging ESI comments. So if you send to ESI payload, which is a ESI comment, and it gets removed, that's a pretty big indication that you're dealing with ESI. If you want to really confirm that it's an actual ESI server, you can do the same thing, but instead of ESI, put something else. Foobar, doesn't matter. If this does come back, then you're probably messing with an ESI server and you should start fingerprinting it. If you don't want to mess with manual detection, you can use either of these three tools. I know for a fact that Burp, ActiveScan++, and Upload Scanner are going to use this heuristic. At Kinetics, however, I don't know how they find ESI. I just know that they claim that they do. If you want to use something like ESI, but you're not exactly sure that this is a safe solution, you can use something that Lucas Ryder on Twitter came up with. So basically, he leveraged Cloudflare workers. Cloudflare workers are JavaScript files sitting on edge servers. Of course, you have to use Cloudflare to use this. And you can use fragments as well. So in your response, you're allowed to have fragments. So here you have a fragment pointing to footer. But the source is not in the response. It's sent in the HTTP header. Now, if you've done any sort of web app pen testing in the past 5 to 10 years, you'll know that HTTP response injection is not exactly common. It's much harder to do. So this is a much safer alternative, and it's probably even faster. So modern ESI, I would call this a modern ESI implementation, and it's just a whole lot safer. Like, you can't inject variables that leaks your cookies. So basically, this is a brief introduction to what ESI is. Obviously, there's still a lot of research to be done on the topic. You can check our blog post, for which we released in April. None of this material was covered in the blog post. This is merely an extension of this research. In our blog post, I think we looked at 6 implementations of ESI, some of which are Akamai, WebSphere, Fastly, Squid, like a whole bunch of them. We found a lot of crashes, like null differencers for Squid. We found header injection, Chrome XSS, filter bypass. So there's a lot of interesting stuff to be found with this. Also, please remember that if you like exploiting caching servers, James Kettle is going to give a really good talk tomorrow about that, so keep that in mind. Otherwise, I could probably close with where we found ESI. So we found a lot of ESI testing our own clients, so I can't exactly talk about that publicly, but a lot of newspaper or organizations that became web-enabled in like early 2000 are still leveraging ESI. Not to say that some are not deploying ESI right now, it's still fairly popular, but like newspaper are usually leveraging ESI for some reason. We found IBM Commerce leveraging ESI. The internals of some Oracle products also use ESI. If you go on Twitter, some people usually put screenshots of where they find ESI injections. Also, I've had people that work for a major bug bounties company told me that they've seen ESI injection bug reports coming through. So it's out there, it's just not exactly popular enough to have a clear picture of where ESI is used right now. So I think we have maybe 4 or 3 minutes for questions. Otherwise, if you want to talk to me afterwards, I'll be at the counter tag Go Secure booth in the vendor area. So yeah, questions. There's microphones right there, or you can say it out loud and I'll repeat, but I'd much prefer you use the microphone.
Could you test on Nginx as well?
Okay, I'm not sure if he asked if Nginx, if I test Nginx. I'm not sure if Nginx leverages ESI, I have no idea. I wouldn't be surprised that someone came up with a module to leverage ESI on Nginx, but I didn't look at it. Yes?
Like the tools, there was Burp, ActiveScan, and a couple others.
Yeah, so there's Burp, ActiveScan++, Burp Upload Scanner, and Akunetics. I think that's it.